So we're going to go ahead and get started. Thanks, everyone, for being here. I am Russell Christopher, product manager for the cloud, essentially, at Tableau. I've been with the company about 6 years. Most of that time I've been here, but I've also been out in APAC. I've done everything from professional services to pre-sales to product management. And I love TC. This is my favorite time of the year. This is like my Christmas. So, Lee?
Hey, my name's Lee Kennedy. I've been with Tableau for 3 years. I've always been in pre-sales. I mainly look after Tableau partners, and I look after New Zealand, where I spend a lot of my time in New Zealand as well as Australia.
Cool. All right. So the title of this session, it's rather long. Intro, okay? So this really is an intro session. How many of you are currently running Tableau Server on AWS? Just show of hands. Okay, so this may be too intro for you. I'll just say that, but you know, if you leave now, that's okay. We will only make fun of you after you leave the room. At a high level, you guys can read this. We're going to talk about sort of what the cloud is. In a very generic way, we'll get into the services of the cloud that Tableau really cares about, the components that we leverage. Then we're going to talk about the big three, right? The big vendors that you can buy this stuff from. And finally, we'll get prescriptive. We'll say if Lee and I were going to go out and buy stuff right now to run Tableau Server on, what would we buy and why? We have lots of time for Q&A, so if you're interested in something, raise your hand. Assuming we stay on schedule, which I think we will, we should have lots of time. We are not, for example, going to talk about all things cloud, for example, data services. We're not going to talk about SQL Azure or Redshift or things like that. We'll touch on that in a more advanced class tomorrow. But again, if you have a question about some of that stuff and it doesn't take too much time, just throw your hand up. So first, we should define what the cloud is. This little company with the definition, you may have heard of them, and they sort of focus on delivery of computing services. And those services can kind of be anything, right? It might be networking, it might be database, it might be the actual server itself, but we're doing that over the cloud. We're doing that over the internet. Actually, I should have put the cloud in quotes and said the internet with my hands down. But the cool thing about this, right, you're going to have to pay. You always pay, but you pay as a utility model, meaning that if I'm at home and I turn the light switch off, I'm not paying for electricity anymore. Or I turn the water off, my water bill goes down. The cloud is more or less like that, which is a good thing. There's some exceptions, but it's more or less pay as you go, which is a good thing. So why do we like Tableau? Or we like Tableau because they pay us. Why do we like the cloud? There are a bunch of reasons, and I'm not going to touch on every single one, but the ones that are important to me, the first one is agility. I love experimenting with different combinations of compute and storage to kind of figure out, for my workload, what makes Tableau Server perform the best. And if I'm on premises, that's a pretty hard thing to do, right? You have to have all these different types of machines configured differently. Realistically, you're just not going to get there. It's really easy to do on the cloud. The other thing that I love is automation. I want to be able to provision my entire environment and auto-install Tableau Server by clicking once, and maybe tear it down by just clicking again, or back the whole thing up by clicking a third time. You can do that on the cloud. And you can do it on premises too, but it's going to cost more, it's more involved. You have to talk to a lot more people and get their buy-in. You can just kind of do it on your own. So this stuff is great for like the lone wolf type. And finally, these platforms have wonderful, wonderful toys, right? They have nothing to do with maybe Tableau or Tableau Server, but indirectly, they allow you to be really creative and help you manage these platforms, just sort of make it easier and more fun. So I love the toys pretty much. The big three.
Cool, this is me. All right, so just to make it fairly clear today, we're going to be focusing on Amazon, AWS, Microsoft Azure, and Google's cloud platform. We're not going to be talking about any other cloud platforms today, like Ali or Baidu Cloud. These are the three that we're going to focus on. Of course, being a Tableau presentation, we've got to include a Tableau viz in here at some point. I mean, this is kind of a struggle with a cloud presentation. How do we fit Tableau into the slides? But here we go. This is a bit of a look at the revenue and market share of the different providers. There's a lot of different cloud providers out there today, but we can kind of see that 4 or 5 of them really dominate in terms of both revenue and market share. I see a lot of you taking photos. I'm fairly sure this will be recorded and shared afterwards as well.
This is stolen right from Gartner, by the way,
Yep.
so just go online too.
This is only their cloud revenue?
This is
Yes.
IaaS revenue,
Yep.
just infrastructure.
Yeah, so AWS revenue versus Amazon revenue, correct. We can see that really 4 or 5 dominate, control most of the market share. In the field, when I talk to customers, I'm really seeing this mirrored as well in the conversations I'm having. Most of them are going to one of the big 3 that we're going to talk about today. And depending on the region that you're in, spend a lot of time in APAC. There are some going to some of the other clouds that are more specific to certain regions in APAC as well, like Ali. So I don't know about everyone here, but often when I come to sessions like this, I like to see hands on the tools early on. I like to see actual demos before we jump into more slides. So I'm going to start by just going through a quick how would you deploy Tableau Server on a cloud platform if you've never done it before. So those of you already on the cloud, you've probably seen this before. Some of you have probably already done this before. But at a high level, we're going to log into an Amazon console. We're going to have a quick look through. We're going to deploy a virtual machine, and then we're going to connect to it, and we'll kick off a Tableau Server install. Then we'll come back later on to have a look at how that's going. And then we'll have a look at one that's pre-baked and ready to go because we have about an hour. I don't want to risk not having Tableau finish installing by then. So I have a pre-baked version as well. All right. So I'm just going to switch across to my Amazon Management Console. I'll just make sure that my login hasn't timed out. We're all good. So I've already logged in. This is the first thing you'll see if you log into Amazon. It looks very similar if you log into Azure or Google as well. You'll basically see a landing page with all of the different services that you can provision with this cloud provider. And they're grouped into logical areas like compute, storage, management tools, databases, and so on. Today we're really interested in EC2, which is Amazon's virtual machine category or Amazon server category. I'm just going to jump straight into my EC2 dashboard. What we see here is a bit of a summary of resources or servers that I have running, different storage volumes, IPs that I have assigned, snapshots, and so on and so forth. We're going to jump straight into launching an instance. So an instance would be a server. And when we launch an instance, we get a quick pop-up to select the operating system that we want. Everyone in here would know that today, Tableau Server is Windows only, with Linux actually in beta today. But we're going to start with a Windows operating system choice. And after we've selected our operating system, what we can see is a list of different server types that we can choose. This is just where we configure how much CPU we'd like, how much memory we'd like, the type of storage category we'd like by default, and so on. I'm going to select something that I know to be a good choice for Tableau. We're going to talk about later on what are some good choices for Tableau in general in these platforms. But I'm going to select an instance with 16 CPUs and 30 gigabytes of memory and continue on to configure some more server details. I'm not going to step through all of these, but what we're seeing here is which network we will deploy our server into, whether we want it to be publicly available on the internet or not, or whether we'd like to join an Active Directory domain automatically, and so on. This screen's a little bit more clearer. We're just adding storage. So how big do we want our hard drive to be? If anyone's installed Tableau before, you'll know that you need 50 gigabytes of free space, or 50 before it will accept your install process. So I'm going to push the hard drive size up a little bit. That will also give me a little bit more performance as well, because my IOPS are tied to the size of the drive in this case. This is simply tags for sorting and categorizing machines. And finally, we're at what we call security groups, which is the easiest way to think about this is like a firewall rule. We've already got a rule for remote desktop, so we can jump in and manage this machine. But we also need a rule here to add one for HTTP, which is web traffic, because Tableau being a web server, under the covers, we need to allow HTTP in. If I was configuring SSL for this, I'd add HTTPS as well. So we get a little bit of a warning here. I've got a security group here that allows this machine to be open to the internet. For today's purposes, that's exactly what I want. And it's telling me that this instance is not eligible for a free tier. Amazon and all of the other platforms have a free tier where you can get a limited amount of resources for nothing. This machine is too big for that tier. Get a summary of my firewall rules and so forth, but everything's all good. I'm going to select launch. And in this case, I need to select what's called a key pair here. Won't go into this in too much detail, but you need to create a key pair when you first launch a machine or when you first sign into the console for Amazon. And this allows you to decrypt your Windows admin passwords later and also allows you to SSH into Linux machines and so forth. Let's hit launch. Yes?
When you do the firewall rule, do
Yeah.
you have to create a new firewall rule for every data source that's going to connect to your server?
Possibly, yes. Yeah.
It just depends on what ports they're coming in and what IP address ranges they're coming in from. So maybe, but maybe not.
Yeah. Cool. So that instance has gone away. It's begun to launch already. I can click on this little unique ID for the instance, which is obviously too hard to remember. And we can see in our dashboard, it's filtered automatically to the instance based on the link I just followed. And I'll just give this a friendly name. And this is Tuesday, or is it Wednesday? It's Tuesday. Cool. So I've given that a friendly name. We can see that it's already running, but it's still going through some initialization phases. So what we'll do is we'll jump back into the presentation, and we'll come back later and connect into this machine and start the typical Tableau Server install process, which would be familiar to many of you. Always do that. Cool. So let's talk about what we just did. So we just deployed a server with a certain configuration for compute. So we'll go through the basics really quickly. When you select a server on these platforms, what you're trying to really do is optimize the combination of CPU or cores or processors, memory, disk, and networking for your workload. So everyone's workload is going to be different. Some of you will be small and medium-sized enterprises where a single node installation might do with a general purpose type VM. Some of you might be much larger organizations where you need to deploy multiple different nodes with different types of CPU and compute because you have more users and more load. What our goal is to find the best combination for Tableau Server in your environment. So we're going to talk through how to select the right type of compute, so CPU and memory, the right type of disk, and we're going to talk about networking as well to wrap it all up. And then we'll jump into what are some good general purpose or some good real-world solutions for you. So compute, typical metrics, this is the same as on-prem. You're going to have number of cores or vCPUs, CPU speed, so the gigahertz that they run out, the generation, so Skylake, Broadwell, and so on, and the gigabytes of memory. So these are all standard metrics for compute. Not super interesting alone, but there are some gotchas that are unique to different cloud providers, and that's what we're going to really dive into a little bit more so you understand where to watch out for and understand what you need to do. The type of machine I deployed before was what's known as a compute optimized family. So all of the instances, it doesn't matter if it's Amazon, Google, or Microsoft Azure, they're all they group their servers into different flavors or different families. You have all-rounders, which are basically what it says is good ratio of CPUs to memory. You have memory optimized, which have typically more memory in comparison to the number of CPUs they have. And you have compute optimized, which typically have a higher number of cores compared to the memory. So there'll be a rough ratio for each of these families of, say, one vCPU is equal to, say, 8 gigabytes of memory for the memory optimized family. There's also probably a half dozen other families like GPU optimized and storage optimized and so on and so forth. But these are really the three that are relevant to Tableau. We're not going to talk about the special purpose families in this presentation. A bit of a refresher on how Tableau consumes compute resources. So how does it consume CPU and memory? There's about a half dozen different things that drive most of this CPU and computation, or CPU and memory utilization in Tableau. I'm not going to talk through all of these, but the big ones that consume the majority of your CPU and memory are viz rendering. So when someone loads a viz and Tableau goes away and renders that for you, that will consume a lot. and background tasks like extract creation, email subscription, alerting, and so on. These are the top two are really the ones that consume a majority of CPU time. So there's some of the things that we're going to talk about today when we look at some results from load testing and so forth. All right, so this is one of the things you need to watch out for. Can anyone tell me what the minimum number of cores is for Tableau Server installation for production? 8, yeah. I'm hearing people say 8. So we have an 8-core minimum for a production Tableau Server install. Obviously, that's lower if you're doing a POC or a trial. But you want to roll into production, we recommend 8 cores as a minimum, which is fine. Deploy on VMware or Hyper-V, you select 8 processes and you're good to go. The way we look at, in the cloud, almost all of the providers use vCPU as their tag. Azure just switched to vCPU as well, but historically they've used core. And in this case, what we're looking for in, say, something like Azure is 8 vCPUs is equal to 4 cores in Tableau. So Tableau Server will detect an 8 vCPU Amazon instance as only having 4 cores. It will still continue to install, but if you want to get the most performance and optimal experience from your Tableau Server, typically to meet your minimum production requirements of 8 cores, you'll typically want a 16 vCPU machine on Amazon or Google. And on Azure, just to make things slightly complicated, some of their older machines, one virtual CPU is equal to 1 core in Tableau. But some of their new machines, they've actually switched to detect in the same way that Amazon and Google does. So some of the newer generations, you'll actually have the same 8 vCPUs is equal to 4 cores and 16 is equal to 8. So that complicates things a little bit because there's no one standard rule to follow for every platform. But there's an easy way to test this. So there's a simple command that takes literally a second to run that will give you an indication of how many cores Tableau Server will detect when it installs. So you see this number on the left here, which is number of cores. This is what Tableau Server will detect when the installation runs. This is what it looks for if you've ever run an installation that says not enough cores found. So what I recommend is you run this. Let's have a look at it. I've got a command window open. Run this command. And we can see instantly on my laptop that this isn't a good idea to run Tableau Server on here. But we can see this has two cores that would be detected by the Tableau Server installer, 4 logical processes. Doesn't take more than 10 seconds to run, and it'll help you validate you've got the optimal number of vCPUs or optimal number of cores for your Tableau Server install. Sorry, Ryan.
Quick question. Does Tableau on the cloud, do you do core licensing?
We do.
Sorry.
How do you compute it then?
What was the question?
The question was, does Tableau Server license per core just like we do on a real machine on premise? Yes, and it is based on this. So in other words,
So how when you're doing licensing, day by day, you're bringing on servers, taking them down. How does Tableau do the licensing?
you're talking about elasticity there, and I think in a roundabout way you're asking, can the licensing flex to allow me to use more for a while and then shrink? That's more of a business issue, and we're actually working through that right now internally to figure out how to allow people to do that. But right now the answer is we don't. In other words, you would purchase for the maximum number of cores that you would need to use, or you just buy interactor licenses, per user licenses, because you can throw as much hardware at those users as you want.
So let's jump in. Let's have a look at some actual data comparing different instance types in Amazon. So what we've done here is we'll switch over to a Tableau workbook. Some of you might have seen this before. These are TabJolt load testing results. So what we're looking at is real-world testing. We're looking at testing against a synthetic load testing workload, number of different workbooks that Russell's tested on different Tableau Server instances, different Amazon instance types. And just to talk through what we're seeing on this chart. So at the top, we're seeing what we call average successful transactions per second. So in this case, it's a user did an action and was that action successful or not? And how many actions could we handle per second? So higher is better in the top part of this chart. In the middle, what we're seeing is the average successful response time. How long did each action take? So lower is better. And lower is also better for the bottom section of this chart as well. This is the average error rate. So lower error percentage is better. What we have here is a few different tests of different families in Amazon. So we have our C4 type in orange. This is our compute optimized type, and we can see that when we switch to an instance with slightly more memory, the M4 type, this is the general purpose, you'll notice that our successful transactions per second actually increases. So what we know is based on the workload that we're testing here, this instance type is a better choice for us. So this will depend on the workload.
So what's compute optimized? You mentioned that.
Yeah, so
What do I get?
What do you get? With a compute optimized instance, you get a certain ratio between memory and CPU. And in this case, you'll get, per virtual CPU, you'll get around 4 gigabytes of memory. So this compute optimized instance, an M4 4XL has 16 CPUs, which means you'll end up with 64 gigabytes of memory in this instance.
And my C4s are also, I'm getting less on the RAM, but I'm getting more on the CPU. I'm getting a better CPU that maybe runs faster. So for certain workloads, a C4 actually might be okay. But in this case, no, the M4 is better.
Yeah. So in this case, we can see that the slightly higher RAM, the double the amount of RAM for the M4, means that we have a longer runway as we increase the number of users against this machine. Our transactions per second stay higher. As we switch to our R4 or memory optimized instance, which has double the amount of RAM again, so around 128 gigabytes of RAM in this case, you'll notice that for this workload as well, oops, if I can click properly, there we go. Yeah. We get slightly better performance as well at higher numbers of users. So what we know from this is that for this workload, a machine with more RAM is better for our purposes. So the point about this is all of your workloads may differ slightly, and with the cloud, it makes it really easy to spin up different machines and load test very quickly to make sure that for your workload, you're getting the most optimal type of machine for your users and from a performance standpoint.
Storage.
All right, and with that, I'm
me.
going
I get to talk
hand
about
over to
storage.
Russell.
So TabJolt is good stuff, right? There are classes on TabJolt this week if you're not familiar with it. It's a really good tool, especially on the cloud. Because you can tinker more on the cloud, you probably need to test more on the cloud too to know if your tinkering is actually worthwhile. So storage. We talked about compute, now we're going to talk about storage. There are two basic types of storage on the cloud. There's block storage and there is object storage. We're going to focus on the former, and that is block storage. Block storage, if you want to think about it, there are various ways to think about it, but I like to think of it as a giant disk drive. Or maybe you want to think of it like a SAN. Essentially, when I need to create a disk drive, I take a little piece out of that, right, and it becomes my disk drive, sort of a virtual volume. And that's oversimplification, but that's good enough. I then take that storage, right, and I attach it to my compute, and now I have a server, right? Now I can do stuff. On the other hand, object storage is a little bit different. First of all, it is really cheap. It's much cheaper to buy than block storage. It's also very durable, like 11 nines of durability, meaning that if I copy a file out to object storage, short of a giant asteroid hitting us, that data is still going to be out there, right? And it probably will be out there. We'll just all be dead, so it won't be very helpful. So you put something in object storage, and then you generally attach a little bit of metadata to it. You tag it with maybe the name of the file or the category of this thing. You typically are going to use object storage for things like backups, archiving, big data. Those of you who've heard about data lakes, right? A lot of those, especially on AWS, the storage where all of that stuff is kept is object storage, right? So a little bit deeper on that. Block storage, you can either get a mechanical magnetic hard disk, right? The disk that we used to plug into our big towers, or you can have flash drives like SSDs. And then on object storage, we've actually already covered this. I'm going to use this for my backups, my archiving, big data, etc. Oh, see, I saw you taking a picture. I went back. Look at that. Service with a smile. Does anyone want to pose in front of this also? We could do that. Okay. So basic requirements for your storage. Lee's already sort of touched on this. We want throughput of 100 megabytes per second for read-write, so the drives have to be relatively fast. We need low latency, so 10 to 20 milliseconds on average or lower. When I say 20 milliseconds, that's as much as we want to see on average for long periods of time. This essentially is a measurement of how quickly is the disk going to respond when I ask it to read or write. If it's really hammered, then it's going to go above that number and the operating system will start to slow down. Therefore, Tableau Server will slow down. Therefore, one of your users calls you and says, Tableau Server's slow, right? And it's not Tableau Server, it's the disk. So just keep that in mind. You want at least 50 gigs of hard disk. A handy-dandy measurement on Windows to use is the perfmon tool that comes on Windows. You want to use average disk second transfer. This will give you that latency number, and you can just watch it in real time as you're doing stuff and get a feel for what you're looking at. Okay, so each of the platforms of the big three, they're going to give you their branded equivalent of hard disk and SSD. They're all kind of about the same with a few wrinkles. At the highest level, never use hard disks, okay? Magnetic, mechanical, bad. So if you're thinking about using hard drives, don't, okay? That's the second thing that I want to say. The third thing is hard disks are generally a bad idea, okay? You actually can run Tableau Server on this and sometimes be reasonably successful for a while. But at some point when your server gets hit hard, these disks are not going to be able to keep up unless you've done really crazy things like striping 20 of them into a single volume. So just don't use hard disks. Be thrifty, but don't be cheap. Let's see, rules of thumb. So now we're talking about the big three. I want to use on AWS general purpose storage. That's SSD storage. Most people just call it GP2, 100 gigs or more. On Azure, I want to use premium disks. That's the P in P20. The 20 represents the size, which in this case is about 512 gigabytes. So I want SSD premium on Azure. And then on Google Cloud, I want 200 gigs of persistent SSD. Now you're looking at these numbers and you're probably thinking, wow, there's a pretty big range there between 100 gigs and 512 gigs. What's going on? Well, in general, performance is tied to the size of the disk volume. The bigger it is, the more throughput that you get, the faster it is. Now, AWS with these GP2 allows us to cheat a little bit, and that's why it's smaller. Their baseline performance is still based on how big the drive is. But these GP2 things have something called burst balance, which allows the disk to temporarily burst up to 3,000 IOPS, which is pretty fast and more generally than enough for what Tableau needs. And you pay for that free fast with tokens. The tokens you get maybe in a bucket, and you use them up, and then they actually regenerate automatically over time. So as long as you don't run out of tokens, you can burst really fast. So this allows you to go with a smaller drive because you have this other thing that works on your side. No, it's not like a Bitcoin.
No,
I'm sorry, no, it's not. It means you can burst for this amount of time or for this amount of data. So don't worry about it because for most people, unless you are doing something like a load test for 8 hours straight, you will never exhaust your burst bucket. It's only if you're just really slamming that machine continuously for long periods of time. So for most people, it's a non-issue.
And they're automatically assigned to the volume. You don't have to do anything special.
Yeah, it just happens automatically. Yeah. Amazon's really good about trying to save people money in this way. So Azure and GCP, it's very easy. It's strictly performance is tied to size, right? All right, so how does Tableau use storage? In many of the same ways that we use compute. Temp files, for example. When we are rendering vises, actually, we create temp files. Certainly when we're refreshing extracts. So what would happen if you were on a hard disk, you didn't listen to Russell and Lee, and it's taking too long to write those temp files when you render a viz? You get the phone call that says Tableau Server is slow. We use the disk for our metadata repository, for our PostgreSQL database, right? And you know you run a database on a good hard drive. So just kind of keep that in mind. And now I'm going to show you some data that kind of backs up what we were just talking about. We will get into Tableau. And a couple of these actually we haven't talked about, but they're just kind of fun, so we thought I'd show them to you. So this is a pop quiz. We have one magnetic hard disk in these 4 tests, and I want you to point out which one it is. Okay, we have a compute optimized machine. Okay, there's the throughput, looks pretty good. We go up and up and up as we add more virtual users, and then you eventually saturate, meaning as I add more users, I'm still not pushing any more activity through the machine. It's dead, essentially. I did the wrong one. Here's the C4. Here is an M4, I believe. Here's another C4 with a GP2 drive, and here is something else. Which is lowest? Which is the magnetic hard drive, based on what you see? Yes, it's this one. Everything is dramatically lower on the throughput. The response time is way higher, and the error rate is way higher. So that's a magnetic disk at work for you, okay? And if you still use a magnetic disk after this, just don't call us. Was there a question here? I wasn't sure. Okay. Now here's GP2. One thing that you can do that I was on the slide but I didn't mention because I wasn't paying attention is that you can buy guaranteed IOPS if you don't want to use GP2. So what I'm showing you now is a disk drive that's been running for about 6 or 7 hours during a test, and it's GP2. And you can see exactly where it runs out of burst balance, right? Throughput goes way down, response time goes way up, and my error rates start peaking. Here's the exact same machine, but I'm now buying provisioned IOPS, which are more expensive. It's a more expensive drive, but it's guaranteed throughput, right? I still go down, but I don't get that steep drop. And again, my response time stays relatively low, right? The cool thing about AWS and their storage is you can actually switch now the type of disk on the fly. So if you knew the Super Bowl was coming and your Tableau server was about to get pounded, you might for 2 or 3 days just want to switch over to provisioned IOPS. You're paying more during that period, but you know you're not going to get that boop that you just saw here. And then finally, encryption. All of these providers allow you to encrypt your data directly on the disk, just a checkbox. And in fact, Google Cloud Platform, for example, you can't turn it off. It's encrypted. So people always ask, well, isn't that going to slow Tableau Server down? Let's test it. The short answer is no. Here is a regular GP2 disk, right? And here is an encrypted GP2 disk. Same machine, no difference. So encrypt away if you see options around encrypting the disk for Tableau Server. Encrypting the disk for like a cloud database, that's a completely different story, and we're not talking about that today. And then finally, let's pretend that you have found the correct yes, will we connect? We'll see if that works or not. You found about the sweet spot on your hard disk size. You may wonder to yourself, I wonder if getting an even bigger hard disk, therefore more throughput, will speed Tableau Server up. We'll answer that question right here. Here is Google Cloud Platform, a 200 gigabyte drive right here, and a 512 gigabyte drive. No difference. Right? So if I bought more storage just to try and go faster, probably just wasted my money, right? If you need the storage, you need the storage. You buy it. Here is AWS. Here is a GP2 drive that never runs out of burst balance, so it's able to burst the entire time, versus provisioned IOPS. No difference. Right? So again, if you buy provisioned IOPS when you don't need that throughput, you're wasting money. And then finally, Azure, same thing holds true. Here is a 512 gigabyte drive versus a terabyte drive. No difference. So again, be thrifty on your storage, even though storage is cheap. Buying more won't necessarily make you go fast.
Cool, we're going to touch on network pretty quickly for sake of completeness. Again, in all of these platforms, the size or the type of server or instance that you buy will have an associated network performance with it, like 10 gig networking under the covers, that sort of thing. In this case, Amazon just categorizes it moderate or high or very high. You can go and look up what these different terms mean. But the takeaway for this is the networking performance within the cloud provider itself. This is what we're talking about. We're not talking about your networking performance between the cloud and your data center or the cloud and your users. This is strictly the performance inside of the provider. This typically doesn't have an impact on Tableau Server, so you don't really need to worry about this networking performance category from the providers. What you do need to have a think about is if you will be running large extracts across your internet link between, say, your on-prem databases and the cloud, you'll need to make sure that your WAN link is large enough to support that traffic volume. So that's where you'll need to, the same for the users, you'll need to make sure that they've got a large enough connection that they can load visits quickly and have a good experience. But strictly talking about network performance, within the cloud providers is typically not an issue. So we're going to talk about some fundamentals around network and architecture more generally in these cloud providers, and they all follow basically the same pattern. We have what's called a geography or a region. This is just the part of the world where you're going to deploy the server. You know, America, Asia, so on. Each of these has one or more availability zones, typically 2 or more availability zones, and you can think of these as like sub-geographies or individual data centers. Within each of these availability zones, we'll have what are called virtual private clouds, which are basically a virtual network where everything within that virtual network is isolated from every other network within the provider. So you don't have an idea that these other VPCs exist. You just have your own little world in which you can deploy resources.
And the virtual private clouds can actually extend across availability zones, which for resiliency purposes is really good, because if this data center blows up, who cares? This one is also running and my stuff can go back and forth between both.
You'll have some sort of gateway on the edge that allows machines internally to this cloud to talk to the internet and vice versa. And within each of these clouds, you'll have one or more or multiple subnets to divide up the networking ranges within these areas. These subnets will also typically either be public-facing or non-public-facing. So public-facing meaning that when you deploy a server or a resource within these subnets, public-facing ones will automatically assign them a public IP, so they'll be internet accessible. Whereas the private subnets will only get a private IP like 10.01 or 192.168 and so forth. They're not going to be directly publicly addressable. So looking at something that was a really basic example. If you just go into, say, the Azure or Amazon Marketplace and hit deploy, you'll get something similar to that, or your first deployment will look like that. But often a more common approach, and one that's kind of mirrors how you do networking on-prem as well, is often you'll deploy your application or database or sensitive servers in a more private network, and then you'll use things like NAT to translate addresses and internet gateways to allow public access through more secure means. So often you might have a reverse proxy in your public subnet, or people might have to come through a VPN into your public subnet and then through to the private subnet. This is a common deployment pattern for Tableau Server as well. I'll show you in a minute a clustered architecture deployment that follows a similar pattern to this. I'm just going to say, we're doing well for time.
We are.
Yeah, so we're going to roll back to the basics, and this is where Russell's going to wrap some of the things up that we talked about.
And this is, I don't even know why we have this slide in here anymore,
but
but you've seen this in online help, right? So we're just sort of tying this back to everything that we've talked about. These are the requirements that we have regardless of where you're going to deploy. 8 physical cores, which means 16 virtual CPUs on compute, 32 to 64 gigs of RAM, which actually means 64 gigs of RAM, even though this says 32 gigs. And again, 50 gigs of hard disk. So there is how you break out your compute and your storage when you look at the non-cloud specific requirements. The instance families that would give you this compute, you saw 3 of them already. We're adding one more to this slide, storage-centric. There's some machines that have very, very high disk throughput and also very big disks. We've done testing on these. They're okay, but they're not very good for Tableau Server. So if you want to use it, great, but typically the ones that you see here that are in bold, those are the ones that we like. The R4s for AWS, which is memory optimized, you get 8 gigs of RAM per virtual CPU. The general machine, M4, we love the M4, you only get 4 gigs of RAM. So you'll get 64 gigs of RAM altogether if you get the right size of this, which is just right. On Azure, the DSV2 is a lower cost machine that works pretty well with Tableau Server. The DSV3, which we'll talk about again in a second, is great. It's very similar in performance to the M4. And then finally for Google Cloud, we want you on a standard machine. So if we really drill down, if we were going to spend money and configure our own servers to run an 8-core Tableau server, here's what we'd buy. That's so awesome. Everything went up at the same time. AWS, Azure, GCP. We want an M4 4X large, 16 vCPU, which means 8 cores, 64 gigs of RAM, and that 100 gigabyte GP2 bursting hard drive. Azure, the D16S. S means that it can use premium storage. And you can see at the far right, we want you on premium storage. There's that P20 we talked about earlier. Same amount of RAM, same number of cores. One thing about this instance type, it's not available on all Azure regions yet. It's a relatively new machine type. So you'll need to look at each region and make sure that that region actually offers this specific machine. And then Google Cloud, the N1 standard 16. Same amount of horsepower on CPU, tiny bit less RAM, and you already know how much hard disk that you need. So you're going to finish this off.
Yeah, let's wrap it up. So we kicked off a machine, or we deployed a machine earlier. So let's follow up and see how that's going. We'll just refresh this one. This is the machine I deployed before. It's got, let's see, I might zoom in a little bit. I realize it's a little bit small. It's got an instance ID. I've got a friendly name for it. We can see a size is a C4XL. I've just gone for a compute optimized one. You can see the availability zone that we're in. We're in Oregon in this case. It's currently running, and my status checks are green. So this is in a good state to now connect to this machine and start the Tableau Server install. We can see a few things in our summary information down the bottom here. These are really important because if we want to connect to this machine, we obviously need to know, what is the address of the machine to connect to, either the public DNS entry or the public IP. And we can see a few other things in here, like if it's running the state, the subnet, the interfaces that it has attached to it, and so forth. So it's really easy to connect to a machine in Amazon, or in actually all of the providers. It's as simple as this. I'm just going to click on Connect, right-click on the instance, click on Connect, download a remote desktop file. If you're familiar with the remote desktop, exactly the same. And I'm going to decrypt the password for this machine. So it's important that you keep those keys that you downloaded earlier when you created them, that you keep them safe. So there's my password. Going to click on Remote Desktop, click Connect. And we're going to RDP in. So fingers crossed everything goes well. We should get a Windows server that comes up here. Just wait for it to wake up.
Loading the profile.
Loading profile, or whatever it's doing
and
under the
Google
covers.
Cloud is even cooler with this. It'll actually allow you to do this stuff right in the browser.
Yep.
You don't even have to use desktop. So that's, I think, pretty cool.
I think it's awesome.
Whatever you want to use.
Yeah.
2016 is great. We're running most of our labs on 2016, but just install on what you have. 2008 R2 or higher.
Cool. And we've got a machine ready to go. Obviously, the next steps would be to, keep getting that error, but that's okay. Would be to go to the Tableau website, download a copy of the server installer, and go through the installation process as normal. Still waiting for this to wake up a little bit. It's the first time I've logged into this machine, so a typical sort of first time login, it's going to take a while to wake up. So we've all seen, a lot of us would have seen a Tableau Server install before. If you haven't, it's as simple as going to our website and downloading the installation file, next. You'll get a basic default install going in about an hour. So let's look at one that we've pre-prepared. So you can see that I've got this filter on my instances here. I'm looking at a specific instance or search filter. If I turn that off, we find that I have around, how many do I have here? 7 different servers running. The one I deployed this morning is TC17, but I also have one that's pre-baked. And all I need to do is copy and paste the URL for this machine into my web browser. And there we go. So that's my Tableau server that I deployed around an hour before I came into this session before. It probably took me about an hour to deploy. Oh wow, I love it when I don't screw my password up in demos. There we go. And there we go. It took me about an hour to deploy on public cloud. All I needed was a credit card, or more accurately, Tableau's credit card. And it's up and running. So that's kind of interesting, but let's look at something more complex I've deployed earlier. So I still touched on automation a little bit earlier. And we have these things called the Tableau Amazon Quick Starts. These are based on scripts that will also work for Azure and for Google if you want to do a little bit of extra work yourself. But we basically have this multi-node or single node cluster deployment that you can click a button and get a finished installation of Tableau Server. So what we're looking at here is an architecture with Tableau cluster with 3 machines in a private subnet. We have a load balancer in front of it, doing SSL offload and all of this cool stuff. This is like a best practice architecture reference for Tableau Server. And all we need to do to deploy this is click on deploy a cluster or deploy a single node. Fill in a few details, like we have to give it our registration information, for example. We have to give it a license key. But after we give it a few of these things, like selecting the availability zones or data centers we talked about earlier we want to deploy into, adding a firewall rule to allow anyone to access this, and filling in a few extra items like the default admin password for my Tableau server. So there we go. My license key, and a lot of these details here, these will look familiar because these are the details that you'll typically fill in on that Tableau registration form after you've installed Tableau Server or desktop. You'll see this. Fill in your registration details. So once I've clicked on all of these, all you need to do is click on Next, and the cloud provider will go away and automatically give you a server, configure the networking for you, configure the load balancers, and provision and install Tableau Server for you without you having to lift a finger beyond this stuff that you'd have to do anyway. So you can take this a step further as well. You can pre-populate all of that information into a file so it can come back to being as easy as one button that you press and it deploys the environment. Yes?
The load balancers in the cloud also?
Yes, the load balancers in the cloud.
And you have to choose to add that?
The script will do it automatically. It will provision the load balancer automatically for you. So you can see these machines here that we've deployed that have these funny tags at the end. These were machines that were automatically deployed by that template that I looked at a moment ago. And the cool thing about this is, I'm not going to talk about this in too much detail because this is in the 201 a little bit more detail. Okay, cool. We get these nice outputs and it just tells me Tableau Server has finished deploying a cluster. It's available at this address. Drop it into here. And that's a Tableau cluster installed, configured, and ready to go. Ooh, almost showed you my password. Without any effort on your behalf. It's a cluster, it's ready to go. Let's prove it's a cluster. There we go. I love that it's all green. That would have been awkward. But there we go. Cluster deployed across 3 different availability zones in Amazon, registered, licensed, ready to go, with very little effort from myself apart from following a wizard. Is that cool? Yeah, cool. Okay. All right. So let's jump back into the presentation. Let's tie this up. We're right on time.
We are.
So At the start of this presentation, I did what's called a manual or self-deployment. I configured a server manually. I configured the Tableau Server installer manually, and I configured Tableau manually. So no difference really than doing an on-prem deployment, except it's a little bit more flexible. You can get your server and infrastructure going more quickly. Just now, I showed you a template or recipe approach. It's built out in the wrong order. Where you have this template or recipe that tells your cloud provider, get me a server this big and get Tableau server installations from this area, and then go away and run a script and do this all for me automatically. So it's like a recipe. It's not a full-on script. It just says, I want a machine this big and these firewall rules, and the provider will figure out how to make that all happen. In the top right, we also have what we call the marketplace offering. This is on Amazon and Azure today. And this is a single-click deployment for Tableau, completely hands-off. You just select the size of the machine you want. Provider does everything for you. And this is a great option generally for POCs or evals of Tableau. The other two options are better for production and final installations. So if you want to prove out Tableau Server and you just want a machine, single click, come back in 30 minutes, 45 minutes, and have it ready to go, Marketplace is a great way to get started today.
Are there differences in cost, or it's just the complexity in setting it up?
So with the self-deploy and the template cost and the marketplace, the infrastructure costs are all identical in terms of if you select a machine with 16 cores and 64 gig of memory, it will cost you the same amount per hour. The marketplace also has an option to pay for Tableau hourly as well. Again, great for POCs, less good for production.
The marketplace offering is cool in that you can pay for it hourly, but there are drawbacks around the inability to upgrade it, and there are several things that it can't do. So really, when you think about marketplace, if you are going to throw that Tableau server away in a short period of time, marketplace. If you want to keep it around, don't use marketplace.
And then there's no difference in cost between the self-deploy and the template?
Yeah, you're just paying Amazon or whomever for the cost of what you're using.
Cool. And now we're on to the summary. So that about wraps it up. We'll run through this summary in 2 minutes, and then we've got time for Q&A.
Let's do even faster than 2 minutes.
Faster than 2
Yeah,
minutes.
speed,
Okay.
speed round.
Compute. Instance choice does matter. There are variations between performance between different types of instances, even with the same number of cores.
I was kidding. Okay. Sorry.
I should know sarcasm being Australian, but apparently not. One vCPU isn't always equal to one core. It's generally a 2-to-1 ratio. You should test this yourself with the WMIC command we looked at a moment ago. Russell?
Oh, storage. Okay. SSD only, right? We've learned, if we learned nothing else, we've learned we don't want to use hard disks. Performance and size are based on the size of the volumes that you provision, and you want at least 100 gigabytes free, and you want that disk to give you 100 megabytes per second throughput and less than, on average, 10 to 20 milliseconds on your latency.
Network. Your WAN speed is probably the most important thing you want to pay attention to. Networking performance for things that talk to each other inside the cloud platforms, generally never an issue. It's really fast networking in between these cloud platforms. It's really fast networking even between different data centers or availability zones. So don't really focus on the networking. Focus on getting Tableau deployed in either a public or a private subnet based on your security requirements, but don't focus too much on the networking speed except for the WAN.
And deployment. You have a couple of choices, right? You can do it yourself, which is fast. You can use templates, which is even faster. Or if you have a machine that, again, you need to use something just to test something or prove it out, and you know you're going to get rid of it, then Marketplace can be a good option for you.
Okay.
There is a template in Azure that deploys Tableau, Cloudera, as well, Hadoop on Windows. And we're probably going to take that basic template and make it a Tableau-only template. So the answer is a qualified yes.
Cool. I'm not going to talk through this. There's some more things that you can learn more about just by Googling these topics. This slide deck will go out after the conference, but Basically now let's open it up to Q&A. Russell and I will hang around for a little bit. I'm not sure about Russell.
Yeah, I'll have to take off, but we still have 5 minutes.
Okay.
The product for an on-prem versus your cloud, what are things that you just absolutely cannot do with cloud-based one that you can do with the on-prem?
So the question was, if I have Tableau Server on-prem and I have Tableau Server on the cloud, what can I not do on the cloud? And when it comes to a self-deploy, in other words, manual, or using this template, the answer is nothing. You can do, it's exactly the same product. When it comes to marketplace, which is why you could probably kind of feel we were pushing you away a little bit from marketplace, you cannot upgrade it. So if you're running 10.3 now and 10.4 came out last week, it's locked down. You would literally have to make a backup of your Tableau server, spin up a new image, and restore that backup to the 10.4 marketplace offering. So it's painful in terms of migration. Also, the marketplace offering does not support Active Directory. Those are probably the two big things. So but that makes the marketplace offering, again, sometimes convenient and sometimes not. Is that?
Are there any data connections that don't work, such as Excel or things like that?
They all, do any of the data connections not work on the cloud? They all work on the cloud. It's exactly the same. Question up front.
Yeah, how do you connect the data when my data is sitting in my company?
Great. So the question is, I have a hybrid connectivity situation. If I want to put Tableau Server in the cloud, how do I let it get to my data, which is on premises, maybe behind my firewall? Lee, you're the expert.
There's a few options. This would be not dissimilar to, say, if your company was geographically distributed and you had data centers in multiple countries and you wanted to connect them together.
There's only one data center.
I'm theorizing. Companies that are really good at solving this already, often they'll have network teams that know how to do it. But at a high level, there's a couple of common ways customers do this. One is by using a VPN to connect securely over the internet your data center to Amazon or Azure or Google. So you'll get a secure link. It'll look like, for all purposes, that your database is accessible from the cloud and you can pull data across. Building on that one a little bit more, a more direct approach is what they call direct connect or interconnect, and the Microsoft name escapes me. But it's basically, there is a way to get a direct link from the cloud to your data center. So it would appear as if they're basically on the same network.
Very fast.
Very fast, very fast.
Yeah. Yeah, like the low end is 1 gigabyte per second. The high end is, I forgot if it's 10 or 100. Clearly, you're going to pay for that.
Yeah.
But if you need, for example, if you're doing just a little bit of extract refreshing against data that's on premises, VPN is probably fine.
Yeah.
But if you're trying to move, hundreds of gigs across the wire to do extract refreshing, a VPN probably isn't going to give you a big enough pipe to do that as quickly as you'd like to. And that's where you think about direct connect.
Yeah. And there's sort of a third option as well. If you're working with data that it's potentially not that secure, if it goes across the internet without a VPN and that's not an issue, then you could just look at asking or working with the IT team to forward ports or open ports in your firewall in the data center and allow the traffic in. And with a little bit more security, obviously you use like SSL for your database connection. You would whitelist or restrict the connection to just the IPs from the cloud and nowhere else. But that's an option for data that might be a little bit less sensitive or, yeah.
Your networking people clearly will not like that. But if you make a good argument, they might say yes.
Cool.
Other questions?
Yep.
In that?
Like the Super Bowl's coming up and you want to change to a different system.
Mhm.
That's redeploying a new instance in the cloud and then doing a backup and restore to that new instance, right? Or is it something?
Repeat the question.
Yeah, so the question was, let's say you've got a busy period coming up and you want to scale up your Tableau Server environment to support extra load that's coming up, correct? Yep. So typically you wouldn't redeploy. Typically you would just deploy another Tableau Server node in the cloud and run that as an additional worker. So you'd start to deploy or scale out horizontally with multiple nodes, and then it makes it really easy to turn those off.
Yes.
It would have license, but so would going from an 8-core node to a 16-core node would also have, yeah.
So you can go both up and out.
Yeah.
You could take your original machine and just make it bigger. Again, that's the advantage of sometimes doing the per user licensing. Because again, if you could have one user on that machine, and if you want to run it on a 50-core machine, like knock yourself out, right? It's completely up to you.
And something Russell touched on earlier, busy periods, if you say want to increase the size or performance of your storage for that period, a lot of the platforms you can do that without any downtime at all, and you'll simply start being charged the extra cost for that more performant or bigger storage. Yeah.
And your scenario is where the wonderful toys come in, because you could actually track how much stuff is coming into Tableau Server, and you could literally write code on these platforms that says, when it gets to X, I just want you to automatically make the machine bigger. And then when it gets back down to Y, make it smaller again. So that's kind of the cool stuff. I think there was one back here.
There's one back here, but for people who do need to leave, I'm just going to put related sessions up as well, but let's take this question here.
In the back? Wasn't there one? No?
No.
Maybe he left.
Sure.
So you talked about up versus out. Do you have a recommendation for the 16 cores?
201, we talk about that, but the short answer is out.
Go out, okay.
Yep. Oh, the question was, if I have 16 cores, should I scale up or out? And I said out. There was a question in the middle here.
I was going to ask about backups.
Mm-hmm.
For mine.
201. But what's your question? How do you do it? Come to 201 and we talk about how to do cloud-based backup, migration, auditing, all sorts of fun stuff. So thank you all. Thank you for dealing with my sarcasm. And
Thank you.